Hello everyone, welcome to Reactify Labs. Today we are going to talk about database replication. Database replication. Okay, so that's it. And as we know that once we have written the topic, it means it's half done. Let's focus on the remaining half. Okay. So what is database replication? As the name suggests, we have to replicate the database, right? So that's it. Even the remaining half is covered now. So looks like we are done. Let's now do the formalities of talking theory. Okay. What is database replication? Why do we need database replication? What are the different types of database replication? So let's talk about that and then we will be done. So database replication involves the duplication and maintenance of data. Involves the duplication and maintenance of data across multiple locations. Obviously, we will not keep all data in one location, right? So, across multiple locations, ensuring continuous data availability, continuous data availability, reliability, and resilience. Okay. So it means obviously database replication, as the name suggests, we duplicate the data and so that we have continuous data availability. Even if one area is down, we have data from another area. Reliability, it means the data is reliable, we can trust the data. And resilience means obviously ability to deal with failure. So even if there is a failure in one place, we can get the data from some other place and our work will not stop. So what are the benefits of database replication? Improved performance, fault tolerance, and disaster recovery, to name a few. So fault tolerance, I just explained why. If one area is down, you can get data from another area. Disaster recovery, yes, if they're again similar, but fault tolerance is one area is down. Let's say there is a power outage, but disaster recovery is let's say somewhere there is a volcano or an earthquake and everything got wiped off. It's a flood. Then still we have data at some other place. It's not lost. So that's why disaster recovery. And improved performance is because let's say uh, our user is in US as well as in India as well as in Australia, but all of them need a very good speed. We cannot give preference to US user and give them fast data by keeping the database near them. So we replicate our database to India as well as Australia, in let's say in every country or every continent, so that everybody gets quick data. Their round trip time gets reduced like this. Okay, so that's why improved performance as well. So now that we know everything about this, let's talk about what are the different types of replication. What are the different types of database replication? So we have something called types of replication. Okay. So first one is snapshot replication. So what is snapshot replication? Snapshot replication involves taking a point in time copy of the entire database. So let's say this is a database it has some data. Let's say it has data till this point. Let's consider data as water, and we have to replicate it. So what happens is entire this data will be copied to this, even if it already had data till this point, but still entire thing will be copied. Okay. So at one point, like let's say we have to copy at point t, at point in time t. So till time t, whatever data was there in this database, everything will be copied to this database. Okay. So this is snapshot replication. So snapshot replication involves taking a point in time copy of the entire database. Pros are straightforward implementation because you just need to copy, right? So let's talk about pros and cons. Pros. Pros is straightforward implementation, suitable for various database environments. So basically straightforward implementation. Straightforward implementation, right? Next is it's very easy, right? So it's ideal for generating consistent snapshots for reporting and data warehousing. For reporting and data warehousing. Okay. And what are the cons? At every point when you have to copy the entire database. Even if there is no change, you will still copy, right? So, and you'll copy entire thing. Even if let's say there is a change of one line, you will still copy the entire thing, which may have a impact on performance. Okay. So potential performance impact. Okay. And next is data may not be the most up to date. May not be the most updated one. Okay. Let's say this is the master database and you have to copy here. Let's say the copying is done every 1 hour or every 10 minutes. So in those 10 minutes, the gap that is between these two databases, the data that's present here is stale, right? So that's why it does not have the most up-to-date data. So that's the con of it. Okay. I hope snapshot replication is clear. Next, let's talk about another type of replication called transactional replication. Transactional replication. Okay. So transactional replication updates the database in real time with incremental changes. Okay. So updates the database in real time with incremental changes. So there will be updates in real time. Okay. Means as soon as change comes to one database, it will be propagated to others, because we need in transaction, we need that guarantee, we need strong consistency, right? So let's talk about pros and cons. Pros are obviously real time update. So it has a real time data, means always fresh data, no stale data, making it suitable for high transaction environments. Making it suitable for high transaction environments, and incremental updates ensure precise changes are applied, means the changes are new. Okay. Let's talk about cons. Complexity increases because the data needs to be real time, right? So every time there is a change, you need to propagate it. So increasing complexity, particularly with high volume transactions. Particularly with high volume transactions. Okay. And also continuous updates. We need to give continuous updates, right? So it has a drawback. Continuous updates can lead to increased resource usage. Increased resource usage. Okay. So I hope this clears transactional replication. Next, let's talk about merge replication. There is something called merge replication. So it combines updates from multiple sources into a consistent database. Combines updates from multiple sources into a consistent database. Means there will be multiple sources from where data will keep on coming, and that's where we say the data is decentralized, and there will be one consistent source where everything needs to come. Okay, it means basically, let's say this database, this database, this database, there are different databases, right? Each one hold their own data. Okay, and periodically these all need to be in sync. So this one, everyone will share their data to this one. Similarly, everyone will share their data to this one. Similarly for others. Okay, so here we need to do merge replication, because each one holding their own data, there can be different types of conflicts, everything needs to be handled, right? So that's where merge replication comes in. What are the pros and cons of this? Pros are supports distributed and decentralized systems. Okay, it supports distributed and decentralized systems. How? By incorporating updates from various sources. By incorporating updates from various sources. Okay, each node can both send and receive updates. As I told you, each database will send as well as receive. So each node can send and receive updates, providing flexibility in collaborative environments. Flexibility in collaborative environments. It means it's not blocking on one database. There is no bottleneck. Every node can read, write, and later share with other nodes. Okay. So what are the cons of it? Complex conflict resolution, because we need a conflict resolution mechanism on every node. We need to know which data is the real data or the latest data, right? So that is going to be a headache. So complex conflict resolution mechanism required. To handle conflicting updates, and managing multiple sources and conflict resolution may increase administrative overhead. Obviously, overhead increase, right? Because you have to manage multiple things. So now we have studied three types of replication. Which one is like good, or which one should be considered when? Okay. So let's talk about considerations for each replication type. Considerations for each replication type. Okay. So first one is snapshot replication. Snapshot. When is it good? It is ideal for scenarios with infrequent data changes and reporting needs. Okay. Ideal for scenarios with infrequent data changes and reporting needs. Okay. It needs consideration of network bandwidth and server resources during snapshot creation, because it is possible that we may have to copy large amount of data. It needs balance between up-to-date data and the frequency of snapshot creation. Like we cannot just say, okay, just copy every 10 minutes, right? So we need to know what should be the ideal time when we should keep on synchronizing. Okay. Next is transactional. So it is suitable for environments with high transaction rates requiring near real-time updates. Okay. High transaction rates requiring near real-time updates. It needs consideration of the infrastructure and configuration required for continuous updates. It needs planning for allocation of server resources and network capacity for ongoing transactional replication, right? Because it's transaction. It's a very important thing. It's a very crucial thing that our database is up to date. So we need to allocate resources in such a way that everything happens in almost real time. Next is merge replication. So it is appropriate for distributed systems with updates from various sources. Distributed systems with updates from various sources. It needs evaluation of the methods and tools for resolving conflicts between simultaneous updates, because if multiple updates come, we need to resolve, right? It needs consideration of the effort required to monitor and resolve conflicts, especially in large scale distributed systems. Okay. So let's talk about some replication strategies now. Okay. So now we will talk about replication strategies. First one is very common. We all must have studied about it or know about it. It's called master slave replication. Master slave replication. So what is master slave replication? As the name suggests, there would be one master, there would be one slave, multiple slaves. So in master slave replication, there is one central master database that handles write operations, while multiple read-only slave databases replicate data from the master. Okay. So there is a master, there are multiple slaves. Okay. So this one will write, this one will, all will read. Okay. So it's very simple. It has advantages like simple. It has a simple setup suitable for read heavy workloads, because there are multiple reads, right? So suitable for read heavy workloads. Okay. But the problem is it's a single point of failure. because there is only one master, and if that goes down and things which were not read will be lost, right? There is one more which is called master replication. It allows multiple databases to act as both masters and replicate changes bidirectionally. Okay, so everyone will be a master basically, master, and like the one which I talked about in the merge replication, there would be different databases and everyone will take the write and update the other one. Okay, so the pros for this is good fault tolerance, uh, improved fault tolerance, and load balancing. Okay, and the cons for this is complex conflict resolution. The conflict resolution is going to be complex. Okay, and because there are multiple databases, and since multiple databases take the writes, there may be data inconsistencies. Okay, and there is one more which is called peer-to-peer replication. So it treats all databases as equals. Okay, allowing them to both send and receive updates. So what's the difference between peer-to-peer and master-master replication? So master-master replication is we will have multiple masters. Let's say this is our earth, so there will be different zones, right? So for each zone there will be a master, and each master will have their own slaves. Okay, but all masters also coordinate amongst each other to update their own database. But in peer to peer there is no concept of slave, everybody is master. Okay, every database is equal. So that's the difference between peer to peer and master. So the pros of this peer to peer replication is it's scalable. Okay, it has no single point of failure, and cons is complex configuration. And potential for conflicts. Okay, so that's it. That's the peer-to-peer replication strategy. Okay, but if we are replicating databases, like we are copying data from one place to other, there are chances that there would be failure, right? And if there is a failure, we need some strategies for failure. So it would be failover strategies. Let's talk about them. One is automatic failover. So what is automatic failover? In the event of the failure of primary database, automatic failover seamlessly redirects traffic to a standby server without manual intervention. Okay. It utilizes health checks and monitoring systems to detect failures and trigger failover. It minimizes downtime and ensures continuous service availability. Let's understand with an example. Let's say there is a master slave architecture. If there is a master and there are slaves, it is possible that masters will go down or may go down. So this automatic failover, what it does is it keeps track of the health of master, and when it sees that okay, master is going to go down, because nothing goes down abruptly, right? So it says that okay, master is not performing well, it's sick, it's going to go down. What it does is it automatically makes one of these a master. Okay, because it predicts it. It utilizes the health checks. and monitoring systems. It detects failures and triggers failover. So this will make master some other one and just give it all the rights of the master. Okay, what happens is this way it knows in advance that it's going to go down, so it makes other one ready to take its place, to take the place of the master. So it minimizes the downtime so that continuous service availability can be ensured. Okay, so second one is manual failover. So one is automatic failover, second one is manual failover. In situations where automatic failover is not feasible or may cause issues, manual failover allows administrators to initiate the switch to a standby server. Obviously, as the name suggests, there will be a man involved. Requires human intervention and decision making. It provides control over failover process, especially in complex scenarios. Let's say there are some times when we don't want this automatic failover, because let's say we are manually trying to bring it down or intentionally making it slow. In that case, I don't want other one to become a master. I don't want the monitor to just assume that it's going to go down when we have done it intentionally. So in that case, manual failover strategy works. Okay, and third one is load balancing. So what is this? It distributes incoming traffic across multiple servers, thus preventing overload on a single server and thus improves performance. Okay, it knows that okay, one server may not be able to hold everything, so it will just distribute the load. And once load is distributed, and each database, let's say, is taking, for example, 100k load, 100k load, then it's better than one database holding 400k loads. And once it goes down, other one will hold 400k loads. So that's when load balancing works. So it utilizes load balancers to evenly distribute requests among replicated databases, and it enhances scalability, ensures resource utilization, and contributes to high availability. Okay, so I hope this database replication is clear. You might have learned something new. Database replication, different types of replication strategies, different types of failover strategies, different types of replication. And yeah, that's it for this video. Please remember to like, share and subscribe. I will see you in the next one.